Yeah, hi. I'm hello everyone. I'm Pranay Reddy Luka. Yeah, I'm student at Fleming College, Toronto, and my student ID is FC10072221, and the course is Project Scope Quality and Risk Management, and the professor is Ganesh Subramanian sir. So yeah, so HIsarna, what it is HIsarna? Uh, it is a technology developed by European Union, uh, and this particularly it is developed to meet climate and circularity targets for the steel industry. Uh, like meet climate, what it means. So while while making this steel, there is a lot of CO2 emission. So in order to check that, in order to uh, decrease the CO2 emission, the European Union asked for the steel industries to reduce it, and they formed a they formed a union and formed a technology which is HIsarna. This was developed and tested in Tata Steel plant, which is in Netherlands. So with this technology, they are able to produce steel efficiency. They are able to increase the efficiency of the steel production. Uh, and with the technology, they redesign the production process. And the target was to reduce the CO2 emission up to 95% by 2050. So this technology helps reduce carbon emissions, ensures energy efficiency, and achieve flexibility in the selection of raw materials in the steel industry. So what it achieves flexibility in the selection of raw materials means. So in the traditional process of steel making, they use most of them use carbon fuels. So in this technology, they use oxygen in order to burn the coal to generate iron liquid. So thus they reduce the usage of carbon fuels, results in reducing the emission of CO2 gases. So yeah, HIsarna is a highly merging of cyclone convert furnace CCF of Tata Steel. It is handled by Tata Steel, and high smelt reduction vessel SRV from Rio Tinto. A new technology for producing steel consisted for a reactor, on top of which iron ore was injected. So in this, the iron ore was like I can show you how the process of HIsarna technology carried out in the next slide. Uh, so yeah, what is ULCOS and what is HIsarna? So just now I spoke about the European Union. They formed a consortium, that is ULCOS, ultra low carbon dioxide steel making. In 2004, 8 steelmakers in Europe, along with Europe 48 universities and research organizations, formed this ULCOS. And what are these main objectives? Like uh, they are looking they are looking to bring improvements in the steel making process. So by reducing the carbon emission and developing and ensuring energy efficiency. So in this process, they almost picked 80 concepts in order to identify technologies and processes that helps reduction of carbon emission, and ensure energy efficiency. From those 80 concepts, they shortlisted four processes, and in that four processes, HIsarna is one of that. So HIsarna is one of the option in the four processes they shortlisted out of 80 concepts they have. So it is started in 2004. HIsarna, it is started in 2004, and so yeah, since 2007, Tata Steel, Rio Tinto, and ULCOS has been actively developing this process. So they started this union in 2004, and since 2007 they started developing this process. They are actively working on this project, and in 2010 they are able to make all the groundwork which are ready to go, and they started the missionary the organizational work in 2011, which is carried out in pilot plant. They built a pilot plant in 2010. So HIsarna development. So how HIsarna technology was developed, and what are the processes that are that goes in order to get the liquid iron uh, in order to make the steel. So you can see from the image um, like how the process will goes. So HIsarna consists of two process steps integrated in a single furnace. You can see the furnace here, and the two processes are CCF cyclone and SRV. So in the pre-reduction and smelting in a cyclone, and it is one, and the final reduction and coal gasification is a smelting reduction vessel. So this is the smelting reduction vessel. So the oxygen, iron ore is and the coal is directly injected into this smelting reduction vessel. So see, what's the difference in the traditional steel making and in the HIsarna is the oxygen and the iron ore and the coal is directly injected, as we can see from the image. Um, so yeah, by using this, they are eliminating. I can show you in the next image how the traditional process used to be, and you can come to know the difference between how it is used to be and how it changed by using the HIsarna process. By using these, so they are able to reduce up to 20% of CO2 emission um, when they are not directly capturing the CO2. If they capture the CO2 directly, so they are able to reduce 80% of the carbon emission, and that is used by carbon capture storage. So see, that is the capture storage, which is directly captured. The carbon is directly the CO2 is directly captured, and it is used for other it is stored and used for other purposes also. There is like no impurity in CO2 by using CCS process. So thus they are able to uh, reduce 80% of yeah, CO2. And SWOT analysis. So what is SWOT analysis? So strength, weakness, opportunities, and threats. A SWOT analysis is a quick way of examining your organization by looking at the internal strengths and weaknesses in relation to the external opportunities and threats. So what are the internal strengths of this project, the HIsarna? So the strengths of HIsarna, you can see from the image, the bottom one is the traditional conventional blast furnace process, and the above that one is the conventional steel making of the HIsarna. So you can see in the conventional blast furnace process, the iron ore and the coal, which is the process for this is made separately, and that is carried out, and those processes are used in order to get make the steel. Uh, and what we call is coking and agglomeration. And in the HIsarna process, the separate steps like the iron ore and the coal, which they are used in different process, different steps to burn it, like heat it. In the Hisarna process, they'll do all by together. So thus by reducing different, like reduced some steps. So low cost coals. The strength, one of the strength is low cost coals. They use low cost coals and low grade iron ores. The heat to reduce and melt the iron ore was produced through oxygen. Uh, I spoke about this before slide, in the before slide. They use oxygen in order to melt the iron. Like they generate heat by using oxygen instead of using carbon fuels. Thus, they reduce the usage of carbon fuels, which leads emission of carbon dioxide. The So by using oxygen instead of using carbon fuels, they reduce at least 20% of CO2 reduction, and 80% of CO2 reduction with CSS. As I spoke earlier, 80% of CO2 reduction is possible with CSS process. And in the by using the HIsarna technology, they are able to reduce emission of dust, NOx, SOx, and other dust particles which are resulted after the, like during the process of steel making. And you can see from the image direct use of fine ores and coal. So the coal and the ores are directly injected into the vessel, instead of carrying separate melting processes for them. They're directly injected. So this is one of the major strength. um, with this technology, it produces high quality steel and using cheaper raw materials. So production of high quality steel, yeah. Recycling of up to 50% of steel scrap. So recycling is one of the major thing in steel industry. Like 97% of the scrap is recycled in steel industry. By using Hisarna, minimum 50% of steel scrap can be recycled and regenerated. And uh, the iron, which holds the magnetic properties, so it won't affect the new products. That, like the recycled products also don't have any difference with the new ones. So these are the strengths. Weaknesses. So what are the weaknesses in Hisarna process? Like like they developed this process in order to reduce the carbon emission, and their aim was to reduce the carbon emission at least at least 50% by 2050. And they are able to make it up to 20%, and they have been developing this technology and trying to make it as better as possible. Complete reduction of CO2 emission was not possible as high temperature required by this. High temperature is required, and in order to in order to burn the steel or iron, in order to burn the coal ores, like they have to use carbon based fuels. By using carbon based fuels, they are going to like the CO2 is going to like CO2 emission will happen, obviously. So like as they are reducing it, but they are not keeping it check completely. And is like there is an other alternate option. In order using carbon fuels, they can use electricity in order to burn these coals, but it requires high capital investment, which is not economical for the companies. And this is a very big weakness, because it is a high capital based. Like in order to convert these complete mechanism into electrical, they have to rebuild rebuild all the organization itself. So it will take huge investment, so and which is not economical for the companies. So, and what are the other weaknesses is like the multi-level governance. Like as it is a big project, it has huge business models and customer behavior, and finance is the major issue. Like as it carries for 10 years, and as it is a very big project, like the finance is the major issue. So opportunities, like the opportunities for the steel industry is its circular economic benefits. Like when they reuse these, the steel industry is the like the major positive in the steel industry. They can reuse any product of it. So by that they benefit at least by 50% of their capital. Like they are not like what can I say, they cannot like yeah. Circular economic benefits, the development of the technologies carried out by different companies. So the Hisarna, the development is carried in different companies, and they build good relationship with each other. Uh, yeah, in that way, the companies have good bonding. With Hisarna technology, the energy efficiency of the steel sector might increase by 20%. By using this technology, uh, the main aim of this technology is to reduce carbon emission and increase the efficiency of the steel, and they are able to do the energy efficiency of the steel by 20%, and they succeeded it. They succeeded to improve the efficiency by 20%, and their target was to uh, um, continuously improve the efficiency of the steel making, and they are able to get 20% of it. And they are trying to rebuild up to of like getting energy efficiency up to 50%. Threats, what are the threats? The major threats are high requirement of capital, as it is a huge project. Like in the initial stage only, the capital, like the planning of the investment was 70 million. And energy intensive production process and high emissions, as it is carbon fuels based process. It has high emissions, high carbon emissions, and the governments are continuously asking them to reduce their carbon emissions. And in the extending scenario of environmental protection policies, steel industry came under heat for its energy consumption and emissions, and it consumes high energy. Like around 6% of walls energy is consumed by um, steel industries. So it has high consumption of energy, and it also emits a high CO2 into the environment. So these two are very negative for the environment and negative for the world also. For that reason, many governments are like focusing on them, asking them for reduce their energy emission, sorry, their CO2 emission to the environment. So that is the one threat. Though over the last few decades, the emissions have been reduced, they still accounted for 6.7% of all the CO2 emissions in the world. So yeah, in the world, and consumed 6% of energy produced globally. So you can see from this point, 6.7% of all the CO2 emission in the world. So only from the steel industry, they are giving 6.7% of carbon emission. So this is very huge, and they are continuously trying to reduce these things, and they're developing technologies. They're using uh, less carbon fuels, using other gases like oxygen instead of using carbon fuels. They're using oxygen in order to heat these. iron ore and coals, the generating heat with oxygens. All these processes are being developed in order to reduce the emission. Though they are trying all these processes, like they're not able to keep in check completely. Like they can do it by introducing new technology and converting completely from using carbon fuels into like electricity. But in order to do that, I just said before in the before slide, in order to do that, they'll they'll require huge capital, and they have to build completely new machinery, and they have to quit this, and they have invested a lot in this, so they are not going to do that. So they are continuously developing, updating themselves, trying to decrease the emissions and competition. So as steel industry is a high uh, recycle high in recycling, so there are high competitions. Like the capital, once you invest it, like the products, they are not going to waste it, they are going to recycle it. So there is obviously high competition in this sector, and political influence, as this is a huge funded sector. Like the capital is very huge, there are obvious chances that political involvement will going to be there. And political influences in the sense, uh, like it will, like it carries up to like 10 years. It will carry like the process will carry for 10 years, and there are the government changes happens, and the political influences could be there on these processes. So yeah, so um, to sum up the HIsarna project, see, the main motive is to reduce uh, carbon emission to the environment and increase the efficiency of steel production, and they are able to do it by 20%. And their target was to increase this percentage to 50%. Yeah, that's it. Thank you.